Okay, Marshall, I'm making a recording of this since we can't seem to get together to help you understand this better. So EPA Refrigerant Study Guide for Service Technicians preparing for the EPA certification test. We will skip over the introduction and go to the first section. So Part A, all applicants, Part A contains core materials that is basic to all types of certificates. All applicants need to study this part of the study guide. So page A2, ozone depletion. Oxygen is one of the more than 100 elements that have been identified by scientists. It occurs naturally in two forms. In one form, two atoms of oxygen combine to form a molecule. Chemists use the formula O2 to represent this form of oxygen. It is very plentiful, making up approximately 23% of the air we breathe. It is important to us because it supports life and is necessary for burning. The second form is a combination of three atoms of oxygen and is not as plentiful as O2. This three atom molecule of oxygen is named ozone and is represented by the formula O3. Like O2, ozone is a gas at the temperature normally found on the Earth and in the Earth's atmosphere. Radiation from the sun causes O2 molecules to react and produce ozone. Our atmosphere is the envelope of air surrounding the Earth. While the major components of our atmosphere are nitrogen and regular oxygen, O2, it also contains small quantities of other gases, including traces of ozone. This atmosphere is made up of several distinct regions, two of which is important to you as a technician. These regions are the troposphere, which is from the ground level to 7 miles high, and the stratosphere, which is from 7 miles high up to 30 miles high. Radiation from the sun produces the ozone layer in the stratosphere. The atmosphere serves as a window through which passes the energy radiated by our sun and received by the Earth. Two forms of infrared energy, which you feel as heat, and ultraviolet energy, which you neither see nor feel. In proper amounts, ultraviolet energy is essential for many life processes. The ozone layer in the stratosphere protects the Earth from ultraviolet radiation from the sun. This is stratospheric ozone, which serves as a protective shield for Earth. Depletion of ozone in the stratosphere is a global problem. Excessive amounts of ultraviolet energy may cause increased incidence of skin cancer and cataracts among humans and may possibly damage the human immune system. Excessive ultraviolet radiation can also hinder the growth and reproduction of marine organisms, plankton, which is the first link in the food chain for marine life. In addition, there is evidence that excessive ultraviolet radiation will reduce crop yields and increase the rate of global warming. As a result of damage to the stratospheric ozone layer, excessive ultraviolet radiation may cause increased rates of skin cancer in humans, an increase in cataracts, damage to the immune system, which keeps you from getting sick, and reduced growth of plankton. There is a growing body of research-based evidence linking stratospheric ozone depletion with the increasing amounts of certain types of refrigerants that have escaped into the stratosphere. HCFC refrigerants contain hydrogen, chlorine, fluorine, and carbon. Page A3. A molecule of modern refrigerant will always contain one or more atoms of carbon and one or more atoms of fluorine. Chlorine is the element in CFC and HCFC molecules that causes ozone depletion. Investigations into the cause of stratospheric ozone depletion over the Antarctic area indicate that CFCs in the stratosphere are a major factor. Because they contain no hydrogen, CFCs are chemically very stable and remain stable when released into the atmosphere. That means they don't evaporate or dissolve. A compound that is chemically stable does not react readily with other substances and does not decompose spontaneously. In addition, CFCs neither dissolve in water nor break down into compounds that dissolve in water. CFCs do not easily break down in the atmosphere. These characteristics of CFCs and HCFCs make them more likely to reach the stratosphere than most other compounds containing chlorine. When CFCs reach the stratosphere, a higher level of radiation causes the CFC molecule to decompose and release reactive chlorine. Once released, the chlorine reacts with ozone, causing the ozone to decompose. It is estimated that one chlorine atom can cause the decomposition of approximately 100,000 ozone molecules. Beginning in the early 1980s, measurements taken over the Antarctic region revealed a marked decrease in stratospheric ozone. Although this has been named the ozone hole, there is no actual hole in the stratospheric ozone. Measurements of HCFCs in air samples taken from the stratosphere is the strongest evidence that HCFCs are in the stratosphere. The following evidence demonstrates that chlorine in the stratosphere is primarily from man-made chemicals rather than from natural sources such as volcanoes. So A, the rise in the amount of chlorine measured in the stratosphere matches the rise in the amount of fluorine, which has different natural sources in chlorine over the same period. So since those two are going up the same, it has to be something that has both of those in it that's causing this. B, the rise in the amount of chlorine measured in the stratosphere matches the rise in ozone-depleting substance emissions over the same period. And C, samples of air taken from the stratosphere over erupting volcanoes show that volcanoes contribute a small quantity of chlorine to the stratosphere compared to CFCs and HCFCs. Ozone depletion potential, ODP. Each CFC, HCFC, and HFC compound has been evaluated to determine its ozone depletion potential. The ozone depletion potential, ODP, is the measurement of a refrigerant's ability to cause ozone molecules to decompose in the stratosphere. CFC-11 or R-11 has been assigned an ODP value of 1. Compounds having less ozone depletion potential than CFC-11 have ODP values less than 1. Those with greater than CFC-11 have ODP values greater than 1. Page A4, global warming. The global warming potential for a gas is a measure of total energy that a gas absorbs over a particular period of time, usually 100 years, compared to carbon dioxide. The larger the GWP, or global warming potential, the more warming the gas causes. For example, methane's 100-year GWP is 21, which means that methane will cause 21 times as much warming as an equivalent mass of carbon dioxide over a 100-year time period. When we look at refrigerants in regards to GWP, HFOs have lower global warming potential than HCFCs and HFCs. Carbon dioxide, also CO2, also known as greenhouse gas, has a GWP of 1 and serves as a baseline for other GWP values. CO2 remains in the atmosphere for a very long time. Changes in atmospheric CO2 concentrations persist for thousands of years. So in this table, you have a refrigerant. So here we have 6 refrigerants. We have R600A, which has a GWP value of 3, R290, which has a GWP value of 3, R441A, which has a GWP value of 0, which are all good for the atmosphere. But over here we have R134A, which has a GWP value of 1,430, R404A, which has a GWP value of 3,922, and R410A, which has a GWP value of 2,088. So let's make a comparison of some refrigerants and their global warming potential in the stratosphere. So A, R134A, which we saw up here, has a GWP value of 1,430. R407C has a GWP value of 1,770. R410A, which we see here, has a GWP value of 2,088. And R600A, which we see here, has a GWP value of 3. Out of these 4 refrigerants, R600A would have the lowest global warming potential on the stratosphere. Also, since we know that carbon dioxide has a GWP value of 1, and R410A has a GWP of 2,088, R410A's GWP is thousands of times greater than carbon dioxide. So using table A above, how do the global warming potentials of isobutane, which is R600A, propane, which is R290, and R441A compared to GWP of HFC 134A, 404A, and 410A? Well, R600A, R290, and R441A are significantly lower in GWP. So these are better for the atmosphere, these are worse for the atmosphere. The higher the GWP, the worse it is for the stratosphere. So using table A above, the characteristics of HFC 134A, HFC 404A, and HFC 410A make them damaging to the environment because they can have a very high global warming potential. Page A5. Hydrofluoroolefins, or HFOs, are non-ozone depleting and have low global warming potentials. HFO, which are hydrofluoroolefins, HFO 1234YF has a ODP value of 0 and a GWP of 4. HFO 1234ZE has an ODP value of 0 and a GWP of 6. So you have ODP, which is ozone depleting potential, and then GWP is global warming potential. In order to discuss ozone depleting refrigerants, in order to discuss ODP, or ozone depleting potential refrigerants, we must discuss halons, CFCs, HCFCs, and HFCs as they relate to ODP value. Halons contain bromine and have the highest ODP values, but are not used in refrigerants. CFCs contain chlorine, but no hydrogen, and have higher ODP values than HCFCs. HCFCs contain chlorine and therefore have some ODP, but also contain hydrogen, so their ODP is less than CFCs. And then HFCs contain hydrogen but no chlorine or bromine, and therefore will not damage the stratospheric ozone. They have ODP values of 0. For example, HFC 134A is a chlorine-free refrigerant, has a ODP value of 0. Of the above types of refrigerants, CFCs have the highest ozone depletion potential. Therefore, CFC refrigerants have the most harmful effect to the stratospheric ozone. R12 is an example of a CFC refrigerant. Okay, refrigerant characteristics and identification. The state of the refrigerant entering the compressor of a refrigeration system is low pressure vapor. HFO refrigerants are less flammable than hydrocarbon refrigerants because they contain fluorine. An example of an HFO refrigerant would be R1234YF. HFC refrigerants contain hydrogen, fluorine, and carbon. HFC 134A or R134A does not contain any chlorine. The difference between refrigerant grade hydrocarbon R290, which is propane, and propane for grills is that the propane cylinders for grilling contain impurities that can damage refrigeration equipment. Some hydrofluoroolefin, or HFO, refrigerants are classified A2L because they are less flammable than hydrocarbon refrigerants, but most are still mildly flammable. HFO refrigerants are miscible in POA lubricants. Let's look up the word miscible. So miscible is something that's capable of being mixed. So like mixable is miscible. This is capable of something being mixed. Page A6, so R410A is a high pressure refrigerant and R123 is a low pressure refrigerant under EPA Section 608 regulations. These refrigerants will be discussed later in Part 2 and 3 of this study guide. R22 and R123 have a ozone depletion of more than 0. R22 has an ozone depletion potential, or ODP, of 0.055, and R123 has an ODP of 0.060. R22 is an HCFC refrigerant and it contains chlorine. Note that the first C in the HCFC stands for chlorine. Also, the first C in CFC 12 or R12 is chlorine. HCFC refrigerants contain hydrogen, chlorine, fluorine, and carbon. So hydrogen, chlorine, fluorine, and carbon. Here in Table B, you have refrigerant R22, which has an ozone depletion potential of 0.055, R123, which has an ozone depletion potential of 0.060, R410A, which has an ozone depletion potential of 0, R502, which has an ozone depletion of 0.23. Referencing to Table B above, R410A has the lowest ozone depletion potential at 0. So this has the lowest. Table C, we have R717, which has a global warming potential of 0. So here's ozone depletion, this is global warming potential. R744 has a global warming potential of 1. R22 has a global warming potential of 1,810, and R32 has a global warming potential of 675. So referencing to Table C above, R22 has a global warming potential of 1,810. The Clean Air Act and the Montreal Protocol. The theory that CFCs and halons emitted into the air could alter the amount of ozone in the atmosphere was first published in the mid-1970s. The widespread public concern is generated it generated led to the U.S. to ban the use of CFCs in a non-essential aerosols in 1978. In September 1987, the U.S. and 22 other countries agreed to control the production and release of ozone-depleting substances. An international treaty that addresses ozone-depleting substances and their alternatives is called the Montreal Protocol. Page A7. In order to stop damage to the stratospheric ozone layer, the U.S. is phasing out the use of chlorofluorocarbons and hydrochlorofluorocarbons. Presently, the U.S. phase-out date for the production and importing of new R22 is set for 2020. After the phase-out of a refrigerant, the refrigerant supply for existing equipment servicing will come from the refrigerant that we have recovered and reclaimed. So they'll still use it by reclaiming what they've already used, like recycling. Knowingly recovering an exempt refrigerant does not violate the Clean Air Act or EPA's regulations. Servicing a system that uses CFCs or HCFCs after the phase-out of those refrigerants does not violate the refrigerant management regulations under the Clean Air Act. The EPA is the enforcing agency. The laws and regulations cover all appliances and other equipment using ozone-depleting refrigerants. State and local governments may establish laws that contain stricter requirements than the Clean Air Act or EPA regulations. The Significant New Alternatives Policy, or SNAP, is a program of the EPA that identifies refrigerants with lower overall risk to human health and the environment. The intended effect of the SNAP program is to promote a smooth transition to safer alternatives. As of 2017, a technician can be fined $44,539 for violating the Clean Air Act, which includes knowingly releasing non-exempt refrigerant from an appliance. In addition to fines and being required to appear in court, they may lose their certification. Clean Air Act Section 608 regulations. To promote conservation of existing refrigerant supplies through reclamation, a standard of purity has been established to ensure that reclaimed refrigerant is not contaminated. Under the EPA's regulations, reclaimed refrigerant must meet AHRI 700 before it can be resold. Servicing existing R22 systems is a lawful use of HCFC 22. Distributors must verify that the purchaser is or employs a Section 608 certified technician before they can sell HCFCs or HFC refrigerants. Carbon dioxide refrigerant can be purchased by someone who is a non-certified technician under Section 608. Section 608 certification allows a technician to purchase or handle controlled refrigerants. All CFC, HCFCs, HFC refrigerant recovery devices must meet EPA standards. Self-contained recovery devices remove refrigerant from an appliance without the assistance of the components of the appliance. Page A8. System-dependent recovery devices relies on the compressor in the appliance and or the pressure of the refrigerant in the appliance. EPA regulations require appliances to have a service aperture or process stub to make it easier to recover refrigerants. That's like that little thing where you take the cap off. Freezers, air conditioning, refrigeration equipment, and commercial refrigeration equipment falls under EPA Section 608 regulations. Desiccant dehumidifiers are not covered under Section 608 regulations. When working with an appliance containing HCFCs or HFCs, a person that is rewiring an external electric circuit is not required to be a Section 608 certified technician. Section 608 certification allows a technician to purchase or handle controlled refrigerants. EPA does not require technicians or the company employing the technician to keep records of the model number and serial number of the appliance when disposing of appliances with 5 to 50 pounds of refrigerants. If EPA regulations change of a technician become certified, if EPA regulations change of a technician becomes certified, it is the technician's responsibility to comply with any further changes in law. So if they change the rules, then you have to follow the new rules. If a technician loses their Section 608 certification card, they should request a replacement from their certifying organization. A major system repair is being performed on an R22 appliance. The technician cannot top off the unit with R410A. Provisions of the Clean Air Act requires the EPA to set standards for refrigerant recovery prior to appliance disposal. When disposal cylinders of CFCs, HCFCs, and HFCs are to be discarded, you must recover all remaining refrigerants, render the cylinder useless, and recycle the metal. Before disposing of any appliance containing CFC, HCFC, or HFC refrigerant, the refrigerant must be recovered. So you're not just letting it out, you have to recover it in another cylinder. Under the safe disposal requirements of Section 608, the final person in the disposal chain is responsible for ensuring that the refrigerant has been removed from the household refrigerators before they are discarded. Clean Air Act venting prohibition. Chlorofluorocarbons and CFCs, hydrofluorocarbons, HCFCs, and hydrofluorocarbons. Okay, sorry, let's start over. Clean Air Act venting prohibition. Chlorofluorocarbons, CFCs, hydrochlorofluorocarbons, HCFCs, and hydrofluorocarbons, HFCs, must be recovered before opening or disposing of an appliance. So you always have to recover this. You can't just throw it away. Page A9. Refrigerants emitted when cutting a line without properly evacuating an appliance that contains CFC, HCFC, or HFC is a violation of the prohibition on venting. During the servicing of a refrigeration system containing either R22 or R410A, the refrigerant must be recovered. CFCs, HCFCs, HFCs, refrigerants must be recovered before opening or disposing of the appliance. Knowingly releasing CFC, HCFC, or HFC refrigerants during service, maintenance, repair, or disposal of appliances is illegal. You do not release, you recover. Release during vandalism or theft of equipment is considered an unacceptable release of CFC, HCFC, or HFC refrigerants. Releasing isobutane from a household freezer is allowed under Section 608 of the Clean Air Act. EPA's refrigerant management regulations exempt refrigerant from the venting prohibition when the EPA has determined that the refrigerant is that type of appliance that does not pose a threat to the environment if released. So you can only release. The EPA determines what can and cannot be released. Release of mixture of nitrogen and refrigerant that results from adding nitrogen to a fully charged appliance to leak check the appliance is considered a violation of the prohibition on venting. Refrigerants and oils. The following statements relate to refrigerants and oils. Alkylbenzene oil is a synthetic lubricant that is used with ternary blends containing HCFCs. You must charge refrigerant blends into the refrigeration system in a liquid state. Blends leak from a system at uneven rates due to the different vapor pressures. Azeotropic refrigerant is a mixture that acts like a single component refrigerant over its entire range. A characteristic of a hygroscopic refrigerant oil is that it readily absorbs moisture. So hygroscopic refrigerant oil absorbs moisture really well. Page A10. The term drop-in refers to a simple change of refrigerant without modification of oil or component. There are no direct drop-in refrigerant substitutes approved for service to replace the R22. Polyester synthetic oil are commonly used in new HFC systems and for retrofitting HCFC equipment to HFC refrigerants. Ester-based oils can be mixed with no other oils. Temperature glide is when a blend of refrigerants has a range of boiling points or condensing points throughout the evaporator and condenser respectively at a constant pressure. This is caused from the blend being a mixture and not a true compound. So let's read that again. Temperature glide is when a blend of refrigerants, so more than one refrigerant, has a range of boiling points or condensing points throughout the evaporator and condenser respectively at the constant pressure. So in other words, you have one refrigerant that, say, boils at 100 and another that boils at 150. That means you're going to have part of it boiling. When that one comes out at 100, it's going to boil, and then it's not, and then the other at 150 is going to boil. A ternary blend refrigerant is a three-part mixture. So ternary, like the TER, that means three. So just ternary, three, both start with T, is a three-part mixture. A leak trace gas is not a refrigerant as it is used in EPA's refrigerant management regulations. The term retrofit refers to a change to an appliance in order to convert it to a different refrigerant. Venting refrigerant from a recovery machine or recovery cylinder is illegal. Remember, you can't vent it out. You have to keep it in something. All refrigerants that are not exempt from the venting prohibition can only be sold to persons who have successfully passed the EPA's Section 608 certification examination. Refrigeration. In this section of code, we will cover the basic refrigeration cycles in general statements that you should already know as technicians. A common pressure gauge for the low side of the system measures pressure in PSIG and inches of vacuum. Manufacturers often color code the exterior of gauges. The color of the low pressure gauge on the typical gauge manifold is set to blue. The color of the high pressure gauge on the typical gauge manifold is